I think most people know Rasu already, but I will, if it's okay, Rasu, I will read from your bio from the University of Alberta. So Dr. Rasu, he has been um, working with honeybees for over 30 years. He received a master's in science and a PhD in entomology from the University of Avas in Iran in 93 and University of Manitoba, Canada, 2015, respectively. So the master's and the PhD. In previous positions as apiculture research scientist in the Animal Science Research Institute in Iran and Alberta Agricultural and Forestry, Canada, Rasu carried out many studies of honeybee biology, control of parasites and pathogens, integrated pest management, and studies of varroa. In addition to teaching graduate and ungraduate students, his extension activities encouraged beekeepers to adopt new and improved methods of honeybee IPM to manage pests and disease using a variety of methods. Recent projects that Rasu worked were focused on new miticides and antibiotics to assist producers in solving challenges related to honeybee parasites and diseases. At the University of Alberta, Rasu will continue his research on the development of new miticides and antibiotics for control of varroa mites and nosema diseases. So I will just pass on to Rasu, and we can use the Q&A. So there's a Q&A chat box on the bottom. If you can see the Q&A, we can use the Q&A to write your questions, and I will help Rasu at the end asking those questions, and Rasu will answer those questions. So we can use the Q&A, but if you'd rather ask live, you can raise your hand, so that there's an icon also on the bottom to raise hand. So you can raise your hand, and I will unmute you, and you can ask Rasu your question yourself if you prefer that way. Okay.
Yeah, thank you. Hello, everyone. Thank you, Renata and Tech Transfer team to invited me for this presentation. Today, I want to talk about the oxalic acid, the method that we use, and how we can use the oxalic acid to control varroa mite. Most of you, I know that you use the oxalic acid for many years to control varroa mite and applied in your colony by different method, and you find that sometimes oxalic acid is very effective, sometimes not. So here we can discuss on that, and I want to review the most study that already did on the oxalic acid. So as you know, if we want to control the varroa mite, we have two options. In a reproductive phase, as you know that the varroa mite reproduce in the silk brood, so we can control the mite or kill the mite in the silk brood cell in the reproductive phase. So I know that the only chemical that affects on the varroa mite in the silk brood is only formic acid. Or if we can use the some queens that already breed for the hygienic behavior, the bees they can reduce the mite level in the silk brood. But in phoretic phase, when the mites came on the adult bees, we have a more exposed to out of the cells, and they can expose to more chemicals. So the most of the chemicals and miticide that we use, like a synthetic or soft chemical, formic acid, oxalic acid, thymol, APVAR, APSTON, all of them affects on the mites when they are on the phoretic phase. So we should be make a decision in IPM, what kind of the chemical we want to use and how we can control the mite. So as you know, we have a variety of miticide in the market, as a soft miticide and hard miticide. Soft miticide is included some organic acid like a formic acid and oxalic acid, and some material based from the plant, like a thymol, like a hopguard, beta acid, and like this. But in hard miticide or the synthetic miticide, we have only 4 products that so far registered in Canada. The oldest one to me is the Apistan, is more than, I don't know, 25, 30 years in the market. And then Checkmate came to market in Canada. And after Checkmate, APVAR was I can say the most effective and popular miticide that the beekeepers use in Canada for over 12 years almost. And after that, in 2016, I think the Varroa came to the market. So, but so far we have a record that the mite show the resistance to Checkmate and Apistan. So it means that we cannot recommend the beekeepers to use this product because this product, they are not effective and they might show the resistance to this. So about the bivarol, as a new miticide, because the bivarol and Apistan, they are from the same chemical class from the pyrethroids. So if the mites show the resistance to Apistan, it's possible they resist the bivarol because from the same family, from the same chemical groups. So if you use the bivarol, please careful about that, because if you might already exposed to Apistan, is very high chance they resist the bivarol. So the only tools that in the hard miticide is left for us to use that is APVAR. But APVAR we used that in Canada for more than 10 or 12 years. So, but recently we heard from some beekeepers that the APVAR is not effective and we have to find a new miticide to replace the APVAR. That's my project with the University of Alberta to check some new chemicals and find a new product to replace the APVAR. So I'm going to encourage you to do if you use the hard miticide like APVAR or bivarol in your apiary, please before that use the resistance test. You know, most of you know that we use the messenger or PETIS test, and recently we provided a new method as an apiarium method in Alberta and another provinces. They want to follow this method to measure resistance to APVAR. So if you use this miticide in your APVAR, please go before that, check if there is no resistance and still mite are susceptible to these chemicals, please use this chemical in your apiary. So I know that the tech transfer team, they have a program this year to track and monitor resistance in the province in Alberta. And I want to ask Renata to give us some more information about this program.
Yeah, so for this program, we'll be launching the registration on June 15th for the mite resistance program. And the registration will be up on our website. Everybody can sign up, it's free. We'll collect samples for resistance to APVAR. So we're doing this program to see if there is APVAR resistance in Alberta. And we're also launching, sorry, my sun is right on my face. We're also launching a Varroa monitoring program as well, together with the miticide resistance program, where we'll have an interactive map on our website. And if you're monitoring for your mite levels, you can enter your data and see in real time what is the mite level in your county, if someone has already also entered their data and things like that. So you can see real-time data that other people are entering for mite infestation level.
Okay, thank you, Renata. So yeah, we know that for Varroa IPM, there is a different methods to control mite. Is a cultural, biological, and chemical method. In chemical, as I mentioned, there's a different chemical, soft and hard chemical available in the market, and beekeepers don't use that. But as you know, if you use and pick some of these chemicals, please rotate them. Never goes only with the one chemicals. If you use a Hopguard, replace next year with Oxalic, and then Formic, Thymol, and Amitraz. And please go and rotate all chemicals to control and delay the develop the resistance in the mite population. So if I want to talk about the only oxalic acid in this presentation, oxalic acid, as we know that there's an organic compound that you can find in the many plants and in the leaves, in the seeds, in the vegetable, in the fruits. But if you use the oxalic acid, they call the organic compound, but actually they are kind of synthetic chemicals because they made by the companies. So if you use oxalic acid in your apiary, please should be protect yourself because oxalic acid is very hazard to your skin and eyes. Protect your eyes by eyeglasses, use the gloves, and also a respirator. So let me to see what is the property of the physical and chemical property of the oxalic acid. Oxalic acid that we use in the apiary to control mites is a kind of the crystal and odorless and strongly is acidic. Color is white or colorless. Most of them they are white, crystal white. And we can solve the oxalic acid in water and also in ethanol. Is very good solved in the both solvent. And sometimes if we give them the high temperature to oxalic acid decompose and convert it to another product, like a formic acid and carbon monoxide. And we can keep them very stable at a room temperature. It means that we can store them in the room temperature. We don't need to keep in the freezer or fridge like this. And sublimate, this product, the oxalic acid can sublimate between 100 and 157 Celsius. So as I mentioned, we can find the oxalic acid in many plants. So if the honeybees collected the nectar or pollen from that plant, is not any problem with residue, and we don't have any residue reported for oxalic acid because we can find in the some honey between 3.3 milligram per kilogram and 761, a very high amount of the milligram per kilogram. Or in honeydew, maximum is around the 119 milligram per kilogram. Or in the another wildflower, maybe 51. So there is no any issue or concern about the residue of oxalic acid in honey. So it's very safe for bees and the bee product to use on the colony. But there's some fact about the oxalic acid. First, if we use the oxalic acid, a study by De Grande Hoffman and the Korea South State, they show that if we treat the packages with oxalic acid, is not very effective because after we set up the packages in the colony, mites, they have a chance to grow up, and again at the end of the summer we have a mite. So, and also oxalic acid doesn't work, as you know, through the capping. They cannot control the mite in the silk brood. And there's some report that oxalic acid damage to the open brood. So if you use the oxalic acid by any method through the time that we have a brood and or actually the open brood in the colony, like mid of the summer or end of the spring, it's maybe the oxalic acid damage to the brood. About how is the mode of action of oxalic acid? We don't know nothing, actually is not clear, and we don't know nothing about how oxalic acid kill the Varroa mite. But we know that oxalic acid in animals linked to some minerals like calcium, iron, sodium, like that, and affects on the biological function in animals. So, but for the Varroa mite, we don't know. Some studies show that when we expose the oxalic acid to varroa mite, maybe low pH of the oxalic acid effects on the mite and use as a factor that they kill the mites. Another study showed that end of the legs of the mite, as you know, the varroa mite has 8 legs that they attach to the bee body, and end of the each legs, I can say end of the finger, there is a kind of the sucking cap they call aurolium, and the varroa mite can use this organ to attach to the bee body and stuck there. So a study showed when we use the oxalic acid like sublimation, subcrystal of the oxalic attached to this aurolium, and actually the mice, they cannot attach to the and stuck on the bee body, and they drop from the bees and they die on the bottom boards. So we don't know actually how the varroa mite kill, how oxalic acid kill the mites, directly affects on the mites and kill the mites as a miticide, or no, just dislodge the mite from the bee body. So for this, we need a more study to clarify this. Overall, as you know, there are four form of the application to use the oxalic acid on the colonies: a spray method, trickling or dripping method, sublimation, and contact. So far, PMRA only registered a trickling and sublimation method for use of oxalic acid in Canada. So a spray method is not registered, and contact method still is not registered, but I know that there is a collaboration between the Ontario beekeepers, CAPA, and CHC to contact with PMRA to register this method, contact method. Because as you know, the oxalic acid already registered in Canada. Only we need an instruction to change or add a new application method as a contact. I hope this will be done through this summer, and you can officially use the contact method in your colonies. So trickling method, as you know, we solve the oxalic acid in a sugar syrup and make around the 3.5% solution, and drip the solution between the frames. Some studies show that this method can have a more than 90% efficacy in the broodless colony, but if the colony has a brood, its efficacy dropped to under 60%. And some studies show that if the application happened in the low temperature, for example, in the end of the fall, because of the bees make a cluster and they cannot, contact with the solution, with oxalic solution, maybe this low temperature decrease the efficacy. So please careful about the time and select the time that you want to use this method. And then a study in Northern Europe showed that if we use the 60% oxalic instead of 3.5, bees, they can tolerate that, but the winter following the treatment with the 6% was very poor than the 3%. This means that with 60%, we can control the mite in the fall, but in the next spring after the winter, maybe we lost some colony because of the high dose of the oxalic acid. And in the study in Alberta showed that is from Dr. Nas from MedHat 2001. They showed that the two different doses, 2.8 and 3.5%. Low dose killed 55%, but the 3.5% of oxalic acid can kill 90% mite, still with the remaining brood. So overall, if you want to use this method in your colony, I think you should go with a 3.5%, to save your bees and also kill the mites. A study in Italy showed that if the guys use the 4.2%, the efficacy or the number of the mite that drops from the colony completely affects by temperature. Every time temperature goes up, this is this line show the average of the temperature in the study area. And average is, you can see in the, it was in 10, it was in I think October and November and then December. So temperature goes down from our average 20% to around the 10%. So every time the temperature goes up after application, for application, you can see the mite drops goes up. So it means that the outside temperature affects on the efficacy of oxalic acid if you use the trickling method. So let me talk about the sublimation method that is very popular. I know in the Alberta and most of the professional or the large operation, they use this large vaporizer. Most of the studies show that the efficacy for this method is between 90–95%. We can use the this method at an almost lower temperature. If we have a low temperature in October or November, is another option to use this sublimation method instead of the trickling method. So, but I think that I want to talk about that, should be careful about use the temperature to supplement the oxalic. Because oxalic acid, if we expose to 250 centigrade, crystal use their water, but still they are solid. And at 350 centigrade, crystal, oxalic acid crystal converted to the gas phase. And if we expose the oxalic acid gas to 372, they decompose and convert it to the formic acid and carbon monoxide. So most of the vaporizer that we use here, we don't know actually what is the exact temperature that you use, and we cannot control temperature. If the temperature goes up and reach the more than 370, we don't know actually at the end of the nozzle, is oxalic acid come out or is formic and carbon monoxide? And maybe formic acid kill the mites, no oxalic acid. But if the mix, this fog is included formic and carbon monoxide, is very hazard for operator. So there is a different kind and shape of the vaporizer in the market. You can provide that. It's dependent on how is your operation size. Some of them is very large for the larger operator, or some of them they are small. For example, is this one, ProVap 110 is very popular in Canada. Most of people use that, or this small one, Varroa wax. These are for the, but for the this vaporizer only we can apply the oxalic acid for one colony once, and we have to reload the this cap or this spoon here with oxalic for the next one. So it makes a time if we have a lots of colony. And I found that this is a new actually vaporizer, the small vaporizer, Varroa 80. This is I think made in Germany. And this vaporizer is very simple. We don't need any power for that because it's supplied by the lithium battery, and you can use so easily under your colony. Yeah, these are the another Varroa vaporizer that they are available in Canada for professional and the larger beekeeper. They can use this for treatment of oxalic acid. There's some study here I want to review that for oxalic acid sublimation. One study by Evans is a new in Pennsylvania. They found that if they use the oxalic acid sublimation, might drop after 3 days, almost 3 days in the oxalic acid treatment groups in compared to the green or control one. Increase the number of the mite drop, but after that is not any difference between control and oxalic acid. It means that when we get them the shot of the application of the oxalic acid in the colony, so the mites drop at the same day, but the next day you cannot see too much mites drop in the sticky boards if you use the sticky board in the colony. So the another thing that the Evans and et al. Found that it was oxalic acid did not impact on the queens and colony population size of brood when we use the oxalic acid in spraying, but honey production in treatment group was significantly lower than the control. And they found that maybe oxalic acid killed some brood when we use it in the spring when our colony has a brood. And maybe this caused the honey production dropped in the treatment groups. Although the Varroa might would be controlled by oxalic acid in the spring and in the summer, but my honey production dropped. So please, if you use the oxalic, careful if you use the oxalic acid in the spring or early summer, should be careful about the honey production in your colony. Another study in Florida by Jack et al. 2021, they used this Prova 110 with 1 gram of the oxalic acid per colony. They used the 1 gram because in a state, EPA suggested 1 gram of sublimation per colony. They used the 1 gram and they found the 1 gram is not effective to control Varroa mite. So they tested different dosages, 1 gram, 2 gram, and 4 grams of the oxalic. And if you follow this color dots, the yellow one is 4 grams, green is 2 grams, this orange is 1 gram, and the blue is control. You can see that after 3 weeks of the treatment, mite level is number of the mite per bee or mite level in the colony from, for example, the 4 gram in the yellow dot from almost 5% drop to the around the 2%. However, EPA recommended 1 gram of oxalic acid per colony. For 1 gram, mite level from 7% dropped by 6%. Is not too much, drop. So they found that 1 gram is not effective for if you want to use the sublimation method to control mites. So they suggested the EPA they have to review the application and correct this method. Another study by Berry, they showed that in Auburn University and Georgia University, this line showed that difference percentage in mite intensity in the control and treated groups by this machine, by Prova. So if you see the purple line in the different 3 different location, the mite is not too much change. Is still the mite level is more than 0, but only in the University of Georgia in 2019 they found the mite level was dropped, and also they use 1 gram of the oxalic acid, and their results show that 1 gram again is not effective, and they suggested should be review the application process and increase the number of the oxalic acid per treatment. So if you use this machine, some beekeepers I know that in Alberta use this machine or another vaporizer, please check the mite control. If the manufacturer suggested 1 gram or 2 gram of the oxalic acid per colony by using this machine, you should be check the mite control. If it was effective, the machine, they can drop the mite level or not. You have to increase the gram of the oxalic acid per application. Another study in Southern England by sublimation method compared with the triclin and spray method. Here I want just talk about the sublimation method. In this graph, they use a different gram of oxalic acid per treatment, almost 0.76 gram, 1 gram, 2 gram, and 4.5 gram. And they found is not very big difference between gram of the oxalic acid. Is completely opposite result of the from the state. From the state showed that the 1 gram is not effective and suggested 4 gram is more effective. But in the South England, they found that no, 1, 2, or half or 4 gram of oxalic acid per colony per application is showed the same efficacy. So again, if you use a sublimation method, please check the mite level, calculate the efficacy to find actually how much oxalic acid you must be applied in your colony. So at the end, I want to talk a little bit about the contact method. Contact method is, I can say, almost a new method in the market, because in this method, the oxalic acid solved in the glycerin as a solvent or glycerol. Glycerin is a sweet and non-toxic colorless and odorless liquid that are used in many, the food and the medication industry. Is very popular in the, most of the food that we use or medication or even the cosmetic product, they have a glycerin. Glycerin is very popular in the human use product. So the guy in the Argentina, they did a study to use the mix of the glycerol and oxalic acid to see how they affects on the Varroa level. So, and so far there are many studies that can you see they use a different application like a shop towel or cardboard to use oxalic, a mix of oxalic acid and glycerin in the colonies. So the study in 2016 in Argentina by Maggie et al., they found that between 86 to 99% efficacy for oxalic acid if we use the 4 steps, I can say 8 steps, or 4 folded steps of the cellulose that each one contain 10 grams of oxalic acid and 20 ml glycerin, mix of the in for each strip. And if the colony treated with 42 days, the mite drop and efficacy is around the 99%. It's very good. It's very good method, and I hope the PMRA as soon as possible register added this method to application. We can use officially this method in our colony. So let me talk to a little bit about this method, a contact method. So the Randy Oliver, after Maggie, they tested different applicators in his apiary. First, he used the blue top shovel to solve oxalic acid and glycerol and soak the towels in the solution and applied on the colonies. And he found this so different result. Here I'm not talking too much about the result. I want to introduce his method. Also, he checked the recently different applicator like acrylic felt handy wipes, pig mat or work wipe, or Q-tip cotton, sponge, chipboard, and maximizer. They are different, like a cardboard or fabric that you can find in the market. And he compared those material, which one is absorb more oxalic acid glycerol and how much they release and how is their efficacy. So among this applicator, Oliver found that the Swedish sponge, this one, the green ones, had actually released the more oxalic acid in compared to the another product. And he suggested this maybe is better applicator to use the mix of glycerol and oxalic acid. So he found that in the study, he found that just for the first, I think a week in the May, between 16 and 21st of the May, he compared different applicator like a cotton and a sponge, acrylic and maximizer. And the results show that the average of the mite drop change from the baseline is mean that how much change between the before and after experiment. He found the cotton is showed a better result in compared to the sponge or acrylic or maximizer. So, but after that, he repeated the experiment and he put a sponge by 1 strip per colony, 2, 3, and 4 strips per colony. And if you see the line green and yellow, red, blue lines show that the starting count of the mite, for example, for the 3 strips, and the 1 colony was 25 mite per colony. But when he put the 3 strips in colony, after 55 days, the mite drop by maybe 2 mite per colony. It's very good. It's good result. So the most of the colony, they show very high drop in the mite. However, in the 2 strip and 1 strip, you can see there is no difference too much between before and after application. And he found that maybe 4 or at least 3 strips is better, give the better result to use the mix of oxalic acid and glycerol. Also, he found that the same result for the maximizer pads. 3 strips and 4 strips showed the better result. Is the mite level dropped by very, very low, 1 or 2% is less than economic threshold. However, the mite level increase in the 1 strip and 2 strips. It means that these low doses of the oxalic acid couldn't control the mite. So this is just a study. I never suggested to use this product. This is just for your information. If you're interested, is your own risk. You can test these applicators. So finally, he showed this result for the sponge and for the maximizer. So he compared 1 strips with the 3 strips per colony. He found that 3 strips is very good efficacy because the total mite in the wash method was like 18 or 19 mites per wash. But after application is dropped to less than 2 mites per wash. And also for maximizer, the same. Mite level in the alcohol wash was around the 17 per wash, but after that dropped to the less than 2. It's very good. It's a good result, but we need a more study actually in Alberta if these applicators working well to use a maximizer or a sponge with the same amount of the oxalic acid. But I think we have to modify this method for our environment because in Alberta is completely different than the California. So we should be modified some part of this experiment for Alberta. And Randy Oliver found about more than 90% efficacy for these 2 applicators. Another study in Canada in 2018 by Ontario Tech Transfer team, they compared different method of the oxalic acid like a drizzle with the strip. They used the strip mix of the oxalic and the glycerol and compared with formic acid and also control groups. They found that this strip, the efficacy was more than 50% in mid of the summer. They used when the colony had a brood. But to me, it's not too much, but it still is need more work to, increase the efficacy in this method. Another study in the University of Guelph in Ontario by Sabahi et al. 2020. It's a new study. So he used a different applicate material and different chemicals like oxalic acid dust, mix of oxalic acid and glycerin. T is a thymol dust, thymol glycerin. OO is oregano oil alone or oregano oil with a mix of glycerin. And they found that for oxalic acid glycerin, when you use the shop towel, was around the 78% mortality. It's very good. But if you see here, just for your information, is not part of the overall presentation. If you compare the oxalic acid with the thymol, thymol dust or thymol with glycerin was around the 90% efficacy. It's very interesting for me in compared to the oxalic. We should be more on thymol to see how is thymol working for us in Alberta. In Alberta also, me and the provincial B team, Dr. Mehmet Nasr, we did some experiment on oxalic acid. In the one study, we compared the different applicators with different vaporizer. In the late fall, it was almost October, November you can see the snow is on the ground. We compared the efficacy of this applicator and some a little bit early season in September, I think. We compare shop towel versus the strips. For the strips, we use the 5 gram of oxalic acid, but for the shop towel, we use a 12 gram oxalic acid, depending on the references that we used. For this machine, we use the 2 gram for this machine, and for the larger machine, for Varrocan, we use the 10 or 12 gram. So the initial result, they are not published yet, but just I want to report here for you guys. So there are two different results. We cannot compare, for example, ProVap with the towel. No, these are completely different, but I showed in the one graph. So ProVap showed the better result than the Varroa Blaster and Varrocan, two large machine, two large vaporizer. And in compare between the strips and the towel, strips at the first glance, when first look at the data, we found the strips showed the better result. They dropped more mite in compared to the towel. And we found the towel, shop towel when we use is not effective like strips, and the mite drop is like a control. So first we found out, okay, we cannot continue the towel, we just should be go with the strip. But we back to the colony and we calculate the mite level. When we started the experiment, mite level was around the 18% or 20% between all colonies. In control, mite level through the experiment increased to 30%, is a normal. But for the both application, for both method, strip or towel, this black or green lines, you can see the mite level drop to less than economic threshold, around 1 or 2%. Interesting. In this graph, we found that there's not too much mite level we collected on the bottom board, on the towel. The strips dropped more mite than the towel. However, at the end of experiment, we found that they have the same efficacy. What's happened here? So we back to the colony because we put a shop towel between, we used the double colonies, when we use the, we put the top shovel between the two boxes. So most of the mite that drop from the top box is stuck on the shop towel. And so we couldn't see any more mites on the bottom board. And we found that very less less mite drop in compared to the strips. But overall, results show that both methods are working and very effective in Alberta. In another study in 2018, we compared, as I mentioned, we compared 3 different vaporizer, one a small one ProVap and 2 larger Varroa Blaster and Varrocan. So this graph showed that the mite level or mite abundance in the colony. All of them, the mite level was started around the 8-9%. All of them, they dropped. You can see the black and the blue line for the ProVap and Varrocan. After just one application of oxalic acid from the first one, of the mite level drop under the economic threshold. This show us that if we can decrease the mite below the economic threshold, we don't need to continue that. If the mite level stay stable on the economic threshold. But we continued that 4 times, and we found that yeah, mite level goes down and reached to the 0%. However, in the Varroa blaster, after third application, mite drop. So what is the message of this graph? It means that if you use several times of the oxalic acid by any method, by straps or by vaporizer, please take a sample randomly from your colonies and you see how much is the mite level. Mite level dropped after 1 or 2 or 3rd application or no, still mite is high. And you need to more application to drop the mite under economic threshold, under 3%. So please use the alcohol wash method to monitor your mite through the treatment. So at the end, I want to just show you an idea about the using mix of the oxalic and formic acid. So this is almost, I can say, a new idea that some guys suggested we mix oxalic and formic to increase the efficacy, because we know that when we use the formic acid that control mite 80–90%, oxalic acid also the same. But if we mix both, maybe we can increase efficacy. In Italy, the guys use the, you can see the name of the, if I can read right, Nash-Hader professional groups. There's a kind of the formic acid commercial name, mask, and VAR Terminator, and control group. So they use 3 different formulation of formic acid. They found like how much was the mortality of mite. But when they mixed that this formic acid with apibioxol is a kind of oxalic acid based treatment. So when we mix the formic and oxalic both, they found that you can see the mite drop efficacy increase in the all 3 treatments. So this is a good idea for us in future working on that to mix the formic and oxalic. And actually we need to know that how much we should be combined, how many percent of oxalic and how many percentage of formic we can combine. And you know that both of the acid, I'm not chemist, but we need a chemist to help us how we can mix it, those acids together to make a very more effective treatment for Varroa mite control. Just I showed this to you just for the, again, give you an idea in future. And if I have a chance, is my plan to do like this, to combine oxalic and formic to see how they are work, how they are behavior in the colony, how they effects on the bees. So at the end, let me, I wrap up my presentation. So I talk about the 3 different methods. Turn off the method of the contact, sublimation, and trickling method. So if you want to find the efficacy, all of them are effective, but contact method studies show that is higher effective than the sublimation or trickling. For equipment that we require, contact is less equipment required in compared to sublimation, because yes, you know that we need a purchase a vaporizer is more expensive. Also, we need a source of the energy like a generator for that. About the cost, sublimation is higher cost to me in compared to the trickling or contact method, because for contact or trickling method is less expense for the cost for beekeepers. They can provide the material and provide the applicators. For operator and beekeeper safety, trickling and contact is less danger for operators in compared to sublimation, because sublimation, they make a oxalic vapor or fog, and is very hazard for the operator. And I told, if the temperature increases more than 372 Celsius, it's converted to carbon monoxide and also formic acid. So they are hazard for operator. And the time that we need, to per colony. So for sublimation is very quick. If we have a, the large operation, we have a 5,000, 10,000 colony, maybe it's more effective to use the sublimation method. Quickly we can treat that colony compared to the contact strip method or trickling method. About the temperature that we can use, sublimation, because we cannot, we don't need to open the colony, we can use that in the low temperature. But for contact and trickling, because we have to open the colony, low temperature maybe is problematic. In the late of the fall, in the, for example, November, maybe it's not good to open the colony and treat them with oxalic. So that sublimation maybe is more helpful in the late fall. And also sublimation need a less labor to me, to treat the colony compared to the another method. So yeah, for opening the colony, for contact and trickling, we have to open the colony, but sublimation, again, no. We don't need to open the colony. We can treat the mites. And depending on how much is our beard operation, our operation size, trickling we can, and contact we can use for the small and mid operation, but for the sublimation we can use for any operation, even the larger one. So what's this point message after these words? It means that if you want to pick one method, contact method, sublimation, or trickling, it depends on how much you want to invest to control the mite. How is your operation size? You have a small few colony, 1 or 2. You have a 5,000 colony, 10,000 colony, 100 colony. So it's up to you to select one effective control and follow the instruction to go with this. And at the end, as I mentioned, trickling and sublimation method is registered in Canada. I suggested to go with this. If you are hobby beekeeper, a few colony you have, you can go with this method because very cheap. But if you have a professional and you have a 1,000 colony, it's better to go with sublimation. And for contact, here I cannot suggested anything to do that or tested any contact method because this method still is not registered in Canada. And thank you for listening to my presentation. And I am ready for question.
Thank you, Rasu. That was really interesting. If anyone has questions, you can either raise your hand and we can unmute you and you can ask your question to Rasu, or you can use the Q&A box to ask your question. That works as well. Either or. While we wait for question, Rasu, I have a question. You did mention about the oxalic acid application you did with MedHat using the strips and the towel. Yeah. You did mention the concentration that you used was, if I wrote down correct, did you say 6 grams of oxalic acid per strip?
Let's go back to the slide. If I remember, yeah, for a towel, we use 12 gram, I think, and for a strip, 5 gram per strip.
5 gram per strip, and you use 2 strips per brood?
No, actually, we follow the Maggie method. We put, I think,
4, I think.
4 folded, or actually 8 strips. Yeah.
Yeah, so 4. Okay, I see. So in total, if you use the strips, then you had 20 grams.
20 grams, half of the Maggie, yeah. Because Maggie used the
choose 10.
40 grams only, and we think maybe 40 is a little bit much. We use the half. We use 20 grams per colony, and it was work. It was good, yeah.
Okay, that was my question too. Yeah, because that paper was 10 grams per strip, and I noticed that you guys used 5, and
Yeah.
in comparison with your shop towel, then if you use 20 grams in total per brood chamber, your shop towel is even less because it's 12 grams,
12 of them.
and you still found similar similar efficacy.
I think I have to explain that. I think we use the 2 towels per colony. It means that 24 gram per colony.
Oh, okay, okay.
Remember details, yeah. Because still we didn't publish the result. We have to work on the data, but yeah, we use I think towel 24 grams for strep. We use the 20 gram per colony.
And that was done when the hive was broodless?
It was in September. They had brood. I cannot say they're completely broodless, but they have a few brood.
A little bit. Do you think, because the study from Maggie was as a summer treatment, do you think that it makes a difference then to have a high, I guess it makes sense to have a higher concentration in as a summer treatment, or do you think you would still think the half dosage would be enough on a summer treatment?
Because if you have a brood in colonies, so it means that you have a source of the mite. And in the summer, we must be careful about the brood safety. I think if you use a 40 grams or more, 50 grams of the oxalic acid in colony, it's maybe effects on the brood, on the open broods. So to me, it's better in the mid of the summer or in the spring, it's better to use a less oxalic, but for the longer time, instead of to put a what shot with the 40 grams, we divided by 4, 10, 10, 10 grams for the longer time. Because when we give them too much oxalic to colony, we maybe kill the broods. Yeah.
Yeah, I want just to add that I have heard from a couple beekeepers that have tried the higher concentration, so the full concentration this year, and they did complain that it did hurt the colonies and it did knock them down a little bit, the population of the worker population, and the beekeeper was not. Both beekeepers, both comments were that they thought it hurt them quite a bit, and they didn't want to use that concentration anymore. So that's very interesting to hear.
It's so easy if the beekeepers use that kind of oxalic acid, this method in the mid of the summer. 1 or 2 days after you give them the oxalic acid in the colony, if you check the bottom board, you can see a small piece of the brood. Most of the white brood is the bees chew that and the drop on the bottom board. It means that the oxalic acid kill the open brood and the bees clean up the cells. Is a sign of the oxalic acid effects on brood. Yeah. Right.
Yeah. Interesting. Well, I'll ask more questions then as well. You talked about the sublimation and using 3.5% concentration for the sublimation.
Yeah.
What is the sugar syrup concentration? Is it that a 1-to-1 sugar syrup? Is it a 2-to-1? Is it a heavy or light?
No, it's a light. Should be 50%, 1/1. Yeah.
Okay, so 1-to-1.
For dripping method, yeah.
Yeah, I find so in that case, I know you say we don't know the mode of action, but in that case, because we're giving oxalic acid and sugar syrup, then the bees are consuming that, right?
Yeah.
Mm.
Yeah. Some studies show that when the bees when we drop the oxalic acid between the frames, bees started to clean up the oxalic drops in the colony, and they consume the oxalic. And the oxalic cause apoptosis or kill the epithelial cell in the bees. You know, they kill the gut cells in the bees. Yeah.
Okay. So
Yeah.
because that is a, I guess they have to ingest that that solution, that would then be more effective only the phoretic mites. So I guess the mites that are on the adult bees, but it wouldn't affect anything on mites and brood cells, that kind of application.
Yeah, right. Yeah, when we use the, in the dripping or also in the sublimation method, we affects and we kill the phoretic mite instead of the reproductive phase in the cells. Yeah.
So it would be more recommended than in either early spring when there's few brood, or late fall.
Brood, or if the, I think, I don't know if you have to, you know, do more experiment in Alberta, but if the mid of the summer in August, for example, is still supers they are on the colonies, if you want to, we have a hive mites and we want to treat them by oxalic, I think you have to give them very, because temperature is high in the summer, in the August, I think you have to give them very low level of the oxalic, no, like a 40 or 50 gram like this. We must give them very low level of the oxalic, but for a longer time.
Okay, okay. And you mentioned, so for the vaporization, you said your recommendation based on studies and things like this would be, the guidance would be to use at least 3 times in 7 days apart. What about for sublimation? Is it kind of the same frequency that would be the guidance?
For a sublimation method, you mean?
Yeah.
For sublimation method, most of the manufacturers that make this vaporizer, they suggested 3 or 4 times, you know, to treat the colony. But again, I should be say that it's better after each, or even after the 4th or 3rd application, take a sample to know how much might dropped, how much is the mite level. Because last fall, a beekeeper contacted me and he used this machine, Prova, on her colony, and she used I think 3 or 4 times of the 2 gram oxalic per colony. Again, after 4th times, she took a sample from the mite. Mite was still high, so the oxalic 2 grams couldn't control the mite it was in, I think, October. Yeah. And I guess her colony still had some brood. And after 4 times application, still the mites came up from the brood to the cluster.
Okay. Yeah. Interesting. Yeah. I'm just checking the chat and the Q&A. Doesn't seem like anyone has questions. I feel like I took a lot of the question time. But I found this very interesting, Rasu, and I learned a bit too. And it's always a good review, I find, to hear what all these studies have found, and what you have done as well. And it kind of is a refresher for us, especially at the beginning of the season, to kind of guide us what to do in the decisions.
Yeah.
I'm sure there are really tough decisions ahead for commercial beekeepers.
Yeah.
And a lot of moving parts, and all this information, I think, is very, very important. So thank you very much, Rasu. Thank you for your time, and for sharing all of this with us.
Yeah.
Thank you.
I hope in future we can do research to, you know, more, adapted this method for Alberta. How much oxalic acid with what method we can is best for the Alberta beekeepers.
Yeah.
Yeah.
Thank you very much, Rasu. Have a great day, great evening. Bye.
Thank you so much, and thank you for present. Bye.
Bye.